In this video, we're going to have a look at what are instances, how you can use them, how they work, what are the pros, what are the cons, and how to set them up and randomize them. So let's have a look. Why should you care about some punk-ass instances when you have some good old copy node? Let's start with this simple example. So in here we have this simple scene, and it's just consists only from our instance, which is alembic, unpacked, and transformed, smaller, and applied material to it. So as you can see, previously it had only 4 points and 4 primitives, so it was kind of packed together. Now it has around 300,000 polygons. And in here it's just a simple ground, grid, some noise, subdivided so it's more smooth, and this is for our render, for our plane. And in here we're scattering some points. To be exact, just 20 points. And what else? We got some simple light, nothing fancy, just straight from the shelf. Okay, and in here we have our copies. So I'm merging in the tree geometry. Remember the 300,000 polygons, so not too big for tree, and the ground. Oh no, actually the scattering points. And here we're scattering the result. And in here we have instances. So in here I'm just merging the instancing points, so those 20 points. Now, what is the difference? We have the same thing in here, same thing in here. Not much of a visual difference right now, but if you can see it has to cook a bit longer, and the larger the geometry, the slower it is. Also, the viewport will start to get slower, but one of the main differences. So let's try to render our copy. We go to render and render it. And now you can notice it takes a little bit of a time, not too much for these 20 copies, but still it takes some time to create a scene and to start rendering. And notice the memory we are using. So it's 3.9 gigabytes, and this is only for 20 fairly simple scenes. And remember, when you're rendering, usually you have to fit your scene into your memory, otherwise you can't render it, or you will be slowed down. And this is especially crucial with GPU renderings, which also a lot of the time you have out of core options, so you can render geometry that doesn't fit into your memory, but it gets much slower. So you should pay attention to how big your scene is and how much you can fit into your memory. And also, if the bigger it gets, the more loading time it needs. So that's that. And notice what happens if we change it for the instance. Push render, and it starts much quicker, and it's exactly the same result. Now this is just 23, so you might say, okay, it's not much of a big of a difference, but let's say we pump it up to 50 trees. So, and let's use the copy now. So I hit render, and now we have to wait maybe double the time of the scene generation, because remember, it has to generate twice as much memory, so it gets so much slower. We're still waiting, and that's fairly simple scene. And notice this, we jump to 5.5 gigabytes. and if I would stop the rendering and render the instances, you can notice it takes almost the same amount of time that it took for the 20 trees. And check this out, like I can go 150, no problem, still 1.5 gigabytes. I can go 300, still 1.5 gigabytes, okay, 1.6, so fair enough. I can go 6,000, still no problem. How much? 1.5 gigabytes more, and we got 6,000 copies, and it's super fast. Even if I go to the viewport, you can see, oh, a lot of them are displayed as bounding boxes, but still it's very fast to navigate, and this is because of the optimize options. Now if I lower it down, I get even less. Let me just slow down the amount, it's a bit too much. Right, so if I go down, I get more bounding boxes. If I put it up, I get more of the geometry, but now the viewport gets much slower. So let's keep it at those 20, which is fairly manageable. Now you can get in there by pressing this icon or by pressing D in the viewport. So that's the main difference, the memory usage. And why is that? Why is it using so much more memory? Well, the thing is, let me just lower it down to something more manageable because it would kill my computer. So, and the difference is, because if you go in here and we have a look at our geometry, you see like this copy is creating physical like copies. It copies, it has twice the amount of geometry. It just takes the whole tree and does exact copy. It copies all the polygons, copies everything. So we have, in here you have 10 times more the geometry. So we have 3 million primitives. Remember, that's 10 times more as we had. And with instances, it kind of creates a copy, but except it's an instance. What that means is it's taking the same exact geometry and it puts it on these points. And these points can have some attributes which you can randomize: the position, the orientation, the scale. So you can randomize your instances so they're not exactly the same. I'll show that in a bit later. So this is why it takes much less memory and it's so much faster. Inevitably, with this approach, there are also, okay, yeah, yes, there are big upsides, like the memory. You can render such a huge geometry, but inevitably with it comes also the downsides. And what are the cons of this approach? Well, the main thing is an instance is an instance, and you can't deform it. Or, for example, with a copy, we can do something like this. We can go in, see, it's so much slower, and since it's a copy, you can just select these points, and we can push and pull them around. You can go in here, and we can select these, add this selection, and just delete it. And you can't do this with an instance. An instance is the exact same thing. Oh, didn't delete it for some reason. Try again. Right. So with copies, because it's a copy and it's physically like duplicating geometry, you can do this. You can transform it with the instance. You can't. It's it's just those points, and that's all you can do. Like place your objects on them, rotate them, scale them, transform them, or in some cases like change the material or change the color or some rendering attributes, and that's it. You can't do this kind of deformations. So if we would have a look, we can now render these changes. Okay, let me find a more decent angle. Right, so now you see these are our changes, the deformation of geometry. So these are some advantages of the copy approach. But check this out, like we have only 10 trees and 2.17 gigabytes. So, theoretically we would be able, if you have a 32 gigabyte RAM computer, you would only be able to fit like how much, like 16 times more, which is like 160 trees or something. So that's not much. And as you saw with the previous approach, we could easily fit in like 10,000 million, no problem with that. So it's much more memory efficient and better for large scale scenes. Let's have a look how you can set up a scene like this from scratch, and how you can set up and randomize some attributes on your instances. So let's just create grid. We can create some geometry that we're going to instance. You know what? Let me use my previous tree example. So this will be, let's call it ground. This will be tree. Now I'm going to just copy paste my geometry from over there, and we can, if we want, we can unpack it and convert it so you get that geometry and the full geometry over there. But actually thinking about not doing it, because it was just for demonstration purposes, and don't really need it in this case. So we'll just make it bigger, 100 by 100 meters. We can put in a mountains up and make it a bit more noisier. Put in some subdivide node and maybe some material node, and we can create some quick materials. The ground, one for the tree. Let's call this ground. This could be our tree. Now let's make the tree greenish. Okay, greenish more. So the tree will be a bit green. The ground will be just this gray ground. Alright, and let's go to the material and assign our ground shader to the ground. Send it out, and we'll have this another out for 3 points. This plugin's got some scatter in here, and let's just make 10 trees. Okay, and let's now create an instance. We are gonna object merge the points we just scattered on our ground. So we're gonna go to the ground and our 3 points, and here we have them, our 10 points for the trees. Now let's put the display flag on this one. Now, as you can see, not much is happening. And why is that? Because first we need to go to instance and turn on fast point instancing. And actually, before that, we should go and put the geometry one to instance, in this case the tree. And now you can see our trees are being instanced. So if we create a distant light and rotate it a bit, now go to the render view, should automatically create the render ROP for us and the camera. Alright, so now we have the trees instancing. It's great. We just need to go to the tree and assign a material to it, which could be this tree material. Oh, just put a null at the end, just for the sake of organization. Okay, and now our scene should be working. Okay, and one tip from Mantra that I want to show you is, if you notice, and I go in here and just scatter 2 trees, you see those 2 points are these 2 guys, and this is our original tree. Now, if I would to turn off the tree, let me go back to the ground and set the display flag correctly. Now, if I would render it, the instances won't render. It's a bit weird, but apparently you need to have your instance object turned on. But now, if you turn it off, your instance geometry is going to render in the center. And you may not want that. So what can you do? Well, a simple thing you can do is go to Render tab and just delete this asterisk, and now it won't render. It still will show in your viewport, but it won't render, so at least that's that. Okay, so the important thing is to set our instance object and set it to fast point instancing. Otherwise, you won't see anything again. So just make sure to check this. And now, you can go in and put as many trees as you like. And it's all good and great. But how can we, well, this is too much uniform. Well, what can you do to randomize these attributes? To randomize your attributes, you can put some special parameters on your scatter points. And the parameters are these ones. If you Google instance attributes, yeah, I think it's called instance attributes, you can find this kind of page, and you see you can put attributes like orient, p-scale, scale, and these other things on your points to randomize your instances. So for example, p-scale, let's just, you know what, we can do it like something like this, yeah. Just create an attribute, make it p-scale, and if you noticed, it's just, p-scale is just one-dimensional, it's just a float. So we can make it, put it on points, make it type float, just size is just one dimension, and we can make a value of, let's say, 0.5. Now if we render it, the trees should be half the size. Okay, that's good, but we want to randomize it on each point, so we can use a attribute randomize nodes and randomize the p scale, make it one dimension, and max value, yeah, let's say from 0.1 to 1. And now we should see varying sizes of the trees. We can make some more trees if we want to. Right, so the trees are now, the size is now randomized. Right, and there's another attribute called scale, and what's the difference? It's the same thing. Well, the difference with scale is you can modify all three axes, like x, y, and z. It's three-dimensional. Now, as you can see, float 3, non-uniform scale. Yep, that's the correct way to put it. It's a non-uniform scale. So, for example, if you just want to randomize the height of the tree, not the width or the length, you can use this randomizing attribute. So now we should put it something like 0.1 on 1. And if you go to geometry spreadsheet, now you can see the scale is 1 on the x-axis, on the y-axis it's random, and again on the z-axis it's the same 1 on all points. So now you can actually see it in here in the viewport. Now if we modify it, you can see how they change. And if let's put it back to 0.1, now if we render it, you can see just the height scales. So that might be useful in some cases, especially with trees. Like if you scale it up and down a bit, it adds another randomization to your points. So then this could be very helpful. Now another thing you might want to do with your instances is randomizing the rotation. Now for randomizing the rotation, usually what I use, let me just put it to something like 2 and 2. So maybe like 5 and 5, so we can see clearly the rotation. Okay, that's kind of ugly. Let's just put something like this. Should be good enough for our purposes. Now, randomizing the rotation. Again, you can use attribute randomize nodes and randomize the orient. You can do this also with normals and up vector, but I prefer this way. Seems to be more handy in other areas. So now orient is a quaternion. As we can see, it's in here. So it's a 4-dimensional attribute. So let's make it 4. And now you see, like, wow, it just goes crazy. So what I found is, I believe you need to randomize which ones. Yeah, this looks correct. So put everything to 0 and put these two guys to 1 and 1, and you should get like a perfect 360 randomization of rotation. Now if you don't like the rotation, you can also change the seat. So as you can see, like, we have some guys rotate it this way, some guys this way, so should be good. We should be good. Now let me put back the scale to something normal. Yeah, let's put something like this. And the P scale, let's put it also to some more decent number. And now if we would rotate render our trees, we should get a pretty decent like randomization. Let me just rotate the view so get better framing. Well, something like this should do the trick. Right, and you can play with values. Let's make some small trees. Let's make these guys like this. And this is how you can randomize your attributes. With Mantra you can also randomize the shaders. I'm not sure how to do that, but I think you can. So you can maybe look into that as well. Alright, and almost forgot the most important thing. So we have instance R3 and it's all good and whatnot, but it's just one tree. I want to instance more trees. I want to instance different geometries to my points. So how do I do that? And let's start with creating another geometry. Let's make it, let's say 5 by 5. Put it so swap the box. We can create a tube. So this will be the tube, and let's make it bigger. So radius, let's say 3 and okay, 5 and 5, and radius height should be, let's say 5, and let's cap and ends. Now let's put it a bit up, and these two as well. Now let's make a material, put a material node on it, and copy, go into the box, paste it, right, and go to the material palette. Let's create two more materials. One will be red, one should be blue, so we'll make this one red. Boxes are red and tubes are blue. Alright, now let's go to the box, let's make it red. Let's go to the tube and make this guy blue. Okay, and let's go to render and turn these guys on. Okay, so we set up our instance geometry. So now how do we randomize it on our points? So let's just delete this. And the thing is, you have to create an attribute, and this attribute is called instance, and it is a point attribute and a string attribute. So now you see we're instancing just the boxes. If I would go on to the points, and you see now I have created an attribute called instance, and it contains the path to the object that I want to render and use as an instance. So now if I would put render, it will render the red boxes. If I change it to tube, it changes all the instances to tubes. But I want to randomize these objects. So for that, you can use again the randomize attribute node. And make it attribute instance and set it to custom discrete. Now this is what I found the easiest way to randomize attributes in Houdini. So yeah, let's make it a string. And we only need three slots because we only have three geometries. So 1, 2, 3, and you see immediately it gets randomized, and we have the same amount of each of them. Now if you want to have more or less of some object, you can lower down the value, make it higher, and just play with the amounts. See, now we don't have any tubes, now we have a lot of tubes, so you can quickly randomize the amount. So most trees, and 0.5 and 0.5 of these objects. So now if we hit the render, we will have randomized objects as our instances. And remember, it's still just some attribute on your points. So for example, if you want, I don't know, let's make less trees, like let's make like 0.1 trees, and let's say in this corner I want to have all trees, for example. I could also use this. Okay, I could select these guys and use name, which is basically also like create attribute, but it's a bit more optimized for string attributes. So instance, and let's put in the name of a tree, and now you can see like whatever I select will become tree instances. So that's another way you can manipulate your instances. So just do a final render and wrap it up. Okay, so the render starts, and as you can see we have our trees in the middle and another objects randomized on our ground. And one more bonus tip for you. How do you create some proxies for your instances? For example, if you have super complicated geometry and you want just simple geo so you can fit more into a viewport, remember, like if we go in here, just disable this, and let's have all these trees. You see, now it's above our 20 million limit. So, you know, with more complicated scenes, it could get quite tricky. So let's pretend that we will have some super high poly box, and we want to have just some simple proxy geometry for it. So this is our box. Now let me just go to subdivide, and we'll subdivide it like, I don't know, 5 times and put some noise on it. Right, so this is our super high polygeo, and we want to have we want to see just a low poly geometry. So for example, this one. See, wherever I set the display flag, that will get rendered. Now what you can do is press Control and click in this corner, and this will set it as a render flag. See, this is a render flag, this purple one, and this is our display flag. So this gets displayed in the viewport and this gets rendered. So now if I would go to the render view and hit render, I should be seeing my high poly geometry things. So this is really cool because you can use like simple geometry in the viewport, but the high detailed geometry, the high poly will be rendered. One thing worth mentioning is also that Houdini has this. If you go to your copy, like remember, if we just copy the geometry, we have now suddenly like we have 6 million polygons. But Houdini has this option to pack an instance your geometry. So now if you have a look, you just have 20 points, and it's much more memory efficient. It's like instancing and it's super fast. So you can maybe do this as well. So now if you would go to the render, it's much more memory efficient. Like for example, let's change the amount to 50. We're still at 1.7 gigabytes, which is very decent. And if we would go in here and uncheck this option, you see suddenly the memory will go up very significantly. It should be back to that 6 gigabytes or something. Alright, the scene is generating, so we're back to almost 5.5 gigabytes of memory used. So that's also an option to consider, but be aware, I think it's a Mantra feature, a Houdini feature, so I know it doesn't work with Arnold, and it probably doesn't work with a lot of other renderers, so be aware of that. So if your geometry is not rendering, like this might also be the cause of it. So it's good to turn it off if you're not a Mantra user, and in the future probably a Karma user. So this is all you need to know when starting with instancing in Houdini. Hope you learned a thing or two, and hopefully see you in the next one. Thanks for watching.